The furthest traveled human-made object is NASA's space probe Voyager 1. Launched in 1977, it reached the outer boundary of the solar system in 2013. It is still transmitting data to Earth and able to respond to new commands. Its batteries are supposed to last until 2025. As of 2016, a signal sent from Voyager 1 takes about 18 hours and 40 minutes to reach the Earth at the speed of light. It will take longer in the future as the probe shoots further still. For a live update of its position, you can check voyager.jpl.nasa.gov. Proxima Centauri belongs to a family of stars called red dwarfs. It is much smaller than the Sun, about 1/7 its size and mass, and has a rather red hue, hence the name. Red dwarfs are very common. Indeed, scientists believe they account for most of the stars in the sky, even though they are too faint for our eyes to see. As you get closer and closer to it, you continuously see it undergo violent changes in its brightness and expel huge amounts of burning hot matter in a rather erratic way. Now, are there any planets around that angry red dwarf? You don't see any. Which is a shame in a way, for although it would be very hard to live comfortably on a planet orbiting Proxima, a civilization rising here would be able to plan for a very, very long future. When our star, the Sun, blows up, Proxima won't have changed a bit. As far as we know, it will still be shining the way it shines now for about 300 times the present age of the universe, a long time by any standards. Being smaller than the Sun, the tiny atomic cores that make up Proxima are fused into bigger cores at a much, much slower pace. Size, star-wise, does matter. The bigger the star, the shorter its lifespan. And for the planets that orbit them, distance is the key. To have liquid water on its surface, and be able to sustain life as we know it, a planet needs to be not too cold and not too hot. For that, it has to be neither too close nor too far from the star it orbits. The zone around a star that allows for liquid water to remain on the surface of a planet there is called the Goldilocks zone. So what if you could find another red dwarf with an Earth-like planet orbiting it at just the right distance? Then it could resemble our gentle world and basically last forever. Feeling somewhat guilty for having had such a thought, you turn around to look at your home solar system, at your home world, expecting the Sun to outshine all the other bright dots in the sky. But that is not the case at all, and the sheer size of cosmic distances suddenly hits you. Were you not pure mind, but instead a real space traveler, how long, you wonder, would it take to send a signal home from here? Were you to be equipped with an interstellar mobile phone, you could have tried to call some friends of yours at each of your stops, to share your discoveries with them. Mobile phones transform your voice into a signal that travels at the speed of light, making communication on Earth seem instantaneous. In outer space, however, distances are usually too large, and nothing seems instantaneous anymore. From the Moon, light takes about 1 second to reach the Earth, and another to return. Had you asked a friend on Earth if he could see you when you were up there, with binoculars, his answer would have reached you 2 seconds later. From the Sun, it would have been worse. Light takes about 8 minutes and 20 seconds to travel the distance between the Earth and the Sun. Conversations start to become tricky, since one must wait more than 16 minutes between a question and an answer. But the Sun is still only next door in cosmic terms. A call dialed now from where you are, near Proxima Centauri, would send a signal that would make a phone ring on Earth in about 4 years and 2 months. Any reply to a query of yours would take no less than 8 years and 4 months to reach you. You have still only got to the star second closest to the Earth after the Sun, but it feels a very long way from home, so you look for something to help locate yourself, so as not to get lost. Remembering the beautiful Milky Way you saw from your tropical island beach, you look around to see where its cloudy white patch of light now lies. To your great surprise, you immediately see that it does not appear as a thick straight line anymore, but like a tilted ring, with some parts brighter than others, and you somewhere inside it. You realize that if it looked like a streak from the Earth, it was because the Earth itself, under your feet, was hiding most of it. Without a second thought, having found no planet around Proxima Centauri, you head straight for the brightest part of the Milky Way. You do not know it yet, but you are now traveling towards the center of a gathering of about 300 billion stars, a gathering that has been called a galaxy. When you think about it, there has to be something peculiar at the center of a gathering 300 billion stars strong. Take the Earth. Its center is the densest, hottest, harshest place there is within the Earth. Take the solar system. At its center lies the Sun, the densest, hottest, harshest place there is within the solar system. This may not prove anything, but it hints that there is probably something big happening at the center of a galaxy too, something really big. As fast as thought, you fly by tens of millions of stars. Some are much bigger than the Sun, doomed to live even shorter lives, and others are tiny, ready to shine their light for time beyond imagination. You also fly through stellar nurseries, dust clouds made out of the remains of hundreds of exploded stars, and stellar graveyards, waiting to merge and become stellar nurseries. And now, there you are, near the galactic center, whatever that means, and you suddenly stop. Right in front of you there is a ring again, a spinning, colorful ring made of scattered matter. Looking more closely, you see it is made of gas and billions of rocks and comets all moving around a thick donut-shaped source of bright, energetic light. What is happening here? What are these rocks and icy fragments that are moving around? You look around a little further, and what you see seems not to be possible. It is not only lost boulders that orbit that ring, there are stars too. Whole stars, not planets, stars themselves, and they are moving fast. Until 2015, one of them actually was the fastest known object in the universe. It is called S2, or Source 2. From the Earth, scientists have seen it complete an orbit around the donut in about 15.5 years. Given the distances involved, that means it moves at an astonishing 17.7 million kilometers per hour. But how can that be? What beast has enough gravitational power to keep such a lightning-fast object close by? Is it even possible to generate such a force? Imagine a marble and a salad bowl. If you spin the marble too slowly against the wall of the salad bowl, it will immediately fall down to the bottom. If you spin it too fast, it will spiral up and fly out to break something in your kitchen. But if you spin it right, it will move around for a moment in a circle, some distance between the bottom and the top, without escaping the bowl, without falling, until friction turns too much of its velocity into heat and slows it down. Now imagine that the marble is this superfast S2 star, and that there is an invisible bowl keeping it in orbit around whatever lies within the bright donut. In space there is no friction, so there is no reason for the star to lose any of its energy. From the speed of S2 we can thus imagine the shape of the bowl, and hence what mass lies at the bottom. Footnote: for fellow scientists who are reading this at this early point in the book, I am neglecting the gravitational waves. End of footnote. This rather straightforward calculation has been made many times by scientists, and it always gives an incredible answer. To create a gravitational field with the right strength for S2 not to be hurled away into outer space, the mass of more than 4 million suns is needed. That would be a huge star indeed. But we have a problem. There is no visible star within the orbit of S2. You can look for one as much as you like. You won't find one. From Earth, To see what this 4 million solar mass object that keeps S2 from flying away is, scientists have built telescopes able to detect specific light that our eyes cannot see, namely either ultraviolet light or, for a more impressive vista, the second most energetic of all the lights we know, X-rays. Using such a telescope, they still cannot see an object, but they do see energetic bursts of light originating within the ring, from some tiny location there. What keeps S2 from shooting away not only isn't a star, it is also far from being as big as it should be. So much so, in fact, that scientists have only one explanation for what must be hiding there: a black hole, a supermassive one. Scientists have called it Sagittarius A star, but they can't really study it clearly from the Earth, its surroundings being hidden by all the stars and dust and gas that lie between its location and our planet. Footnote: for history lovers, Sagittarius A star was actually first detected using a radio wave telescope in February 1974 by American astronomers Bruce Ballack and Robert Brown. End of footnote. You, however, are right next to it, and if you wonder what triggers these bursts of energetic light that telescopes on Earth detect, you are about to find out. Understandably, though, being right next to an invisible monster, you don't feel very secure. Who knows what a black hole could do? Could your mind get swallowed, possibly never to be reunited with your body? Could it get stuck in there and doomed to wander away from everything you know? Or could there be a hidden passage, a door leading to another universe, to another reality, as you may sometimes have heard people say? Uncertain what to do, you stare at the billions of tiny particles of dust and other small rocks that make up the bright ring. Less than a minute later, a huge potato-shaped asteroid flies past you at 1 million kilometers per hour. You watch it carefully. As it speeds through the ring, you see it melt into tiny specks of molten matter, burnt by the friction caused by the ring's dust. Just as a small rock entering the Earth's atmosphere might become a shooting star and burn up entirely without making it to our planet's surface, the asteroid disappears long before it could reach whatever lies inside the donut. As you turn around again to look for more action, it is not just a big piece of rock that you now see coming your way. It is a star, a big, shining, furious star, like S2, but bigger still. Will it burn too? Will it get through? You see it dip towards its fate and fly through the donut at an angle. It is now within the ring and out of sight, but it promptly reappears after completing half an orbit in a strangely distorted way, as if a mirage caused by some weird force caused it to change shape. It continues to fly down. Tremendous stresses seem to be acting on it. Planet-sized chunks of the star are snatched off its surface. You try to stay calm, praying that there is nothing to fear, but you can't help it, and your thoughts suddenly feel weary and heavy, preparing for a disaster of mind-bending proportions. Until now you were ethereal, oblivious to whatever forces were ruling the universe, but that is not the case anymore. Loaded with heavy thoughts, you become subjected to gravity, and you are in the presence of its master. Against your will, you are dragged inwards. You are being sucked in, as if sliding on an invisible yet slippery slope. You cross the ring of heated matter and get close to the infalling star, now ripped apart, as it bursts into a blazing wing of white-hot plasma that spirals downwards, taking you in, towards the still invisible black hole. Needless to say, your fears are all justified. Hundreds of billions of tons of plasma are plunging in with you. Your heart beats like mad as you spiral down faster and faster and faster until a tremendous whirlwind force ejects you out. What remains of the star is transformed into extraordinarily powerful jets made of what seems to be matter turned into pure energy. Confused, you wonder if you've just slid into a parallel world inside a black hole, but you soon realize that you didn't, that you are moving away from the monster, that you've been ejected or rejected by the master of mass. The Milky Way's giant ring is now apparent again, far away. Like that marble made to spin too fast against the wall of a salad bowl, you and the dust from the disintegrated star have been expelled before having reached whatever the black hole is made of. You fell in too fast and got slingshot away before reaching the invisible monster, and so did the star, whose matter turned into two jets of the most energetic types of light known to mankind, X-rays and gamma rays. One is shooting up and the other down, like two beacons aiming their lights not just to the gaping space between the stars of the Milky Way, but further still, towards greater voids. The jet's speed is astounding, and so is yours. You are being carried away and fly by millions of stars, as if a giant finger wearing the Milky Way as a ring was pointing to your destination. Maybe it wasn't yet time for you to take the plunge into a black hole. Maybe nature wanted you to see more of our universe's beauties before allowing you to travel within a black hole's deadly grip. Whatever the reason, your heart recovers and your thoughts become light again, ridding your mind of gravity's grasp. You are far away and have recovered the freedom to move as you please. Still, you follow the jet for a moment to see where it leads, and it doesn't take you long to see that something strange is happening. The surrounding stars seem to be less and less numerous, so much so that soon there aren't any ahead of you anymore. Some sources of light are still shining far away in the distance, but they really are much further than anything you've seen so far. Strangely also, the Milky Way ring is gone. Wondering where it went, you look down and gasp at the most extraordinary vista you've ever seen. No human being or man-made object has ever been blessed with such a sight. Earth-based observations have sneaked a few images of the surrounding of the black hole you've just escaped, but not of this. Were you to call Earth from your present position, a reply, if any, would take more than 90,000 years to reach you. You are above the Milky Way, your galaxy. If you thought, looking up at the night sky from your sandy beach, that it must spread all the way to the end of the universe, you now see that it doesn't. Far from being everything, the Milky Way is but an island of stars lost in a dark immensity of a far larger scale. The first men to have been to space all came back humbled by the beauty of our planet, and by its tiny size in an ocean of blackness. But that was just the beginning. What you are staring at now is more humbling still. You knew the Milky Way was a galaxy, but only now do you see what that really means. From above, or below, it makes no difference, the whitish cloud in the Earth's night sky doesn't look like a cloud at all, but like a thick disk made of gas and dust and stars. Right underneath you, spreading over distances so large that light would take tens of thousands of years to cross, 300 billion stars, bound together by gravity, are spinning around a bright center. If you think of the solar system with its planets and asteroids and comets as our cosmic family, if you think of Proxima Centauri as our neighboring star, then the Milky Way can be thought of as our cosmic megalopolis, a thriving city 300 billion stars strong, the Sun being just one of them. Intertwined within a whirling dance, surrounded by emptiness, it is such gatherings of stars and dust and gas that scientists call galaxies, and just as our star has been named the Sun, the Milky Way is the name we have given this particular galaxy, our galaxy. 4 huge bright spiral arms separated by dark patches swirl around its center, where they meet up in an even brighter bulge of gas and dust and stars that hides everything, down to the black hole you've just escaped. Only the jet of energetic matter being expelled from it, the jet you've traveled with, is visible from where you are. If you have a hard time grasping what 300 billion stars floating on their own actually means, Do not worry too much about it. Nobody really can. But if you were to try to explain what you were seeing from up there to your friends once back on your tropical island, numbers won't help. Instead, tell them to pick a cubic cardboard box 1 meter high and fill it to the top with coarse sand from your beach. Now ask them to fill 300 such boxes with the same sand. There are as many stars in our galaxy as there are grains of sand in all these boxes taken together. Kindly ask your friends to fly back to London and pour the contents of these 300 boxes in a disc shape covering Trafalgar Square, and to draw 4 spiral arms on it. Then tell them to sit on Nelson's shoulders. That's what the 300 billion stars of the Milky Way look like to you now. And if you tell your friends that you marked one of the grains of sand with a yellow dot before they winched themselves up, ask them to figure out which one it is. They'll realize how hard a time your mind is having up there above the real Milky Way, figuring out where the sun is, not to mention the Earth, which is 100 times smaller. Finding a star is hard, but planet hunters have a harder job still. From above the Milky Way, to find the sun, your mind does, however, have an advantage over your friends. You can imagine all the night sky pictures that have ever been taken by humans, from Earth and from space alike, to compare them with what you now see. Over the years, scientists have created a map of our galaxy's stars, and without ever leaving the Milky Way, they have a fairly precise idea of where the sun and the Earth lie within it. To match the pictures of the night sky, you first concentrate your efforts near the galactic center, near the bulge and the black hole, where all is bright and beautiful and powerful. Wouldn't it be natural for a species as important as ours to have blossomed in, or quite near, that very special position? Wouldn't it be logical, given our importance, and so very right, for the sun and the Earth to be part of that galactic magnificence? Well, they are not. The solar system lies about 2/3 of the way between the central black hole and the outskirts of our galaxy, somewhere on one of the 4 bright arms. Not a special place whatsoever. And to further rub salt in the wound, as you shall now witness, however huge it may be compared to us, even our galaxy itself is pretty insignificant on the cosmic scale. Turning around to face whatever is left out there to see beyond the Milky Way, you catch sight of some shining blobs that seem to light up the far distant universe. You wonder, are they loose stars, these blobs? They seem a bit too smeared out, and far away. Are they? Could they be galaxies too? Can you see them from the Earth with the naked eye? The answer to the latter question is no. On Earth, every time you've raised your eyes towards the night sky, all the stars you have ever glimpsed a twinkle of belonged, and still belong, to the Milky Way galaxy, to the spiral disk you've just seen. All of them, even those stars that seem rather far away from the whitish band that streaks the night skies. The Milky Way is not an infinite sphere, but a finite disk, and the Earth happens not to be at its center, but rather closer to its edge. Different directions in the sky hence look very differently filled with stars, just as the night sky is different, seen from different places on Earth. Each place faces a different part of the Milky Way. It so happens that the Earth's axis is tilted in such a way that the southern hemisphere always faces the galactic center, while the northern hemisphere always looks away from it, where there are far fewer stars. Accordingly, nights in the north are rather dull compared to southern ones. From your tropical island beach, what you called the Milky Way was just a slice of your galaxy, a band containing hundreds of millions of stars too far away to be seen individually, but whose lights, together, formed the cloudy band. As you now peer into the faraway unknown, ready to make your mind bounce towards whichever place you find most mysterious, you suddenly realize that all these blobs of light look as fuzzy as the Milky Way. They must be galaxies too. And as you think so, Right there, at an angle, another galaxy suddenly rises. The sight is astounding. Its edge appears from underneath the Milky Way, and it is now growing fast. It is Andromeda, our local galactic big brother. It is so big that it is hardly believable that it took so long for mankind to discover what it was. From Earth, Andromeda spans a part of the night sky that is about 6 times as large as a full moon. But it is so far away that despite its 1,000 billion stars, only its central bulge can be spotted with the naked eye, and that bulge is tiny. The first human to notice it, and whose written records reached us, was the extraordinary Persian astronomer Abd al-Rahman al-Sufi. Around the end of the first millennium, more than 1,000 years ago, when many throughout the world spent their short lives fighting each other, inventing cunning torture devices and fearing the end of the world, he watched the stars. Al-Sufi was one of the greatest astronomers of the Golden Age of Baghdad, but describing Andromeda's central bulge as a faint cloud of light, he had no way of knowing that it was another galaxy. He did not even know what a galaxy was. Actually, that knowledge came about 1,000 years later. No one knew about galaxies as separate gatherings of stars until the 1920s, and the observational works of Estonian astronomer Ernst Öpik and US astronomer Edwin Hubble. They were the first to notice that there were great expanses separating these other groups of stars from the Milky Way, making them separate entities in their own right. Some had thought about that possibility before them, though, the first of whom seems to be the 18th century English astronomer and mathematician Thomas Wright. A few years later, the German philosopher Immanuel Kant elaborated on his idea. Andromeda is the closest cosmic proof that the Milky Way is not the entire universe. As you look at it, as you realize that the Milky Way and this majestic spiral of 1,000 billion stars whirl around each other, you also become aware that all the galaxies in the universe are engaged in a cosmic ballet, a ballet where the dancers are lone shining islands, gatherings of billions of stars moving within the dark emptiness of space. Spanning the cosmic horizon, an extraordinarily powerful feeling crosses your mind as it starts to encompass the Milky Way and Andromeda and other galaxies both near and far. In a pure, blessed moment, you suddenly see everything. Tens, hundreds, thousands, millions, hundreds of millions of galaxies, everywhere forming groups of various sizes, forming weird filament-like structures that crisscross the whole visible universe. Who would have thought? A few minutes ago, or is it hours, you were lying on a beach, on holiday, and now the entire visible universe is contained within your mind. You've reached such a viewpoint that the dots studding the universe are not lone stars anymore, but groups of galaxies, each group containing thousands of galaxies, themselves made out of hundreds or thousands of millions of stars, the Milky Way being but one of them. As you embrace this amazing picture, as you look at all these places, you can't help thinking that you'd have the same trouble finding your home galaxy out of all the others as you'd have finding the sun within the Milky Way or a grain of sand in Trafalgar Square. Still, you set your mind free and shoot at the speed of thought and see galaxies spin and dance and whirl and get torn apart and smash against one another, and you witness tiny ones disappear as they purely and simply are swallowed by some giant neighbor. Now wait. Should you worry about that? In a blink, you are back near the Milky Way. Andromeda is overhead. It is huge. Could it be that it too will one day merge with the Milky Way? The two galaxies are certainly moving around each other, but something else is going on. Sharpening your gaze, you suddenly jump as you realize that Andromeda and the Milky Way really are falling upon each other at the astonishing rate of 100 kilometers per second, leaving just 4 billion years before they collide. They will start to merge 1 billion years before the sun explodes. Gulping painfully, wondering how humanity could ever be saved from that, a note of relief crosses your mind. Galaxies are so big and there is so much space in between any stars within, the galactic collisions hardly ever make stars smash into one another. There is a risk, sure, but you'll have to live with it for now. It is absolutely normal at this stage to go through a Copernican philosophical depression. You may even begin to wish you were still living a few millennia ago, when the Earth was flat and, for the obvious reason that we humans like to consider ourselves special, at the center of the universe. How reassuring it must have been to believe that everything revolved around us, that angels were spinning some sacred wheels attached to a cosmic clockwork mechanism, making the stars and the sun move. Why on earth did the 15th century Polish mathematician and astronomer Copernicus have to ruin all this and proclaim that the sun was not orbiting the Earth? Why did the 17th century mathematician and astronomer Galileo see that Jupiter had moons that were not orbiting the Earth, or the sun for that matter, since they were orbiting Jupiter itself? Why did Öpik and Hubble see that there were other galaxies out there? Why? They started all this. Well, besides the fact that they were right, without the likes of Copernicus and Galileo and so many others, humanity would be doomed, and, which is arguably worse, I would never have written this book. You would never have traveled by thought alone through our cosmic vicinity, not to mention beyond, as you are about to do. And between you and me, wouldn't it be a shame if all the beauty that is hidden out there were left unseen or unexplored, or, worse still, left only for other intelligent species to see from their own faraway cosmic perspective? I have written other intelligent species here, but as English theoretical physicist and cosmologist Stephen Hawking often jokes, or does he, we've still to find proof of intelligence here on Earth. And again, while we're on the subject, and as the sheer size of the visible universe starts to sink into your mind, do other species actually exist? Within those billions upon billions of star groups that stud an otherwise dark universe, are there red dwarfs like Proxima Centauri circled by planets of their own? Are there double sun systems shining upon inhabited worlds? Are there other Earths? It may seem scarcely possible to believe we're alone in this gigantic universe. If it's just us, seems like an awful waste of space, wrote US astronomer and cosmologist Carl Sagan in 1985, and yet 30 years later, no one from Earth knows. The existence of alien life is still an exciting possibility, and a scary one too, granted, but for now it's just that, a possibility. This may change very soon, however, as our telescopes start discovering more and more worlds out there. I, for one, very much hope so anyway. Even during some of the darkest years of humanity's chaotic past, some people heroically defied the religious authorities by asserting that indeed other worlds probably existed. The Italian Catholic monk, Giordano Bruno, for one, got burnt alive in Rome in 1600 for having dared to speak such a heretical thought out loud. He had claimed that there were countless suns and countless Earths, all orbiting around their suns. He died in agony for believing so. Today, even if, in my opinion, far too many people, even in the most developed countries, would rather play deaf and blind than face some facts unraveled by science, we know better than any inquisition. Potential Earth-like planets have been found, and the likes of Giordano Bruno have been vindicated many times over, albeit rather recently. Humanity has known about the existence of planets like Jupiter or Venus for ages, that is true, but the first time in history someone actually saw a planet orbiting a star that is not the Sun was only 20 years ago, when in 1995 two Swiss astronomers, Michel Mayor and Didier Queloz, spotted a giant world which they called 51 Pegasi b, orbiting a star located about 60 light-years away from us. The planet Maio and Kelo found is not habitable, though, if only because it is far too close to its star. Still, it is a planet. Following their discovery, a few other such worlds were found each month, until specially devised satellites were sent to find more. NASA's Kepler telescope, launched in 2009, is one of them. Today, more than 6,000 candidate worlds have been detected. Out of these, about 2,000 have been confirmed as being planets orbiting faraway stars. Some are even double star systems, planets orbiting two suns, and many other surprises are sure to break future news. To differentiate them from Venus or Jupiter and the other planets that are part of our Sun's family, these faraway worlds are all called exoplanets. And, by the way, out of the 2,000 confirmed exoplanets, about a dozen are potentially Earth-like, and at least 3 of them, whose existence was confirmed in 2014, do bear stunning similarities with our Earth. The 2015 one is called Kepler 442b. All of these other worlds may be barren, of course, but they may also harbour life. In fact, I'm ready to bet that direct or indirect signs of extraterrestrial life will be found within the next 2 decades or so. Maybe on one of these candidates, or on some yet-to-be-discovered ones. The technology is almost there for us to detect signs of biological activity within the atmosphere of such remote worlds. It would be great to live through such a discovery, wouldn't it? Now, all the exoplanets that have been detected so far are within the Milky Way, our galaxy, and thus rather near to Earth. Planets that could exist in other galaxies are much too far away for any of our telescopes to spot, even though there may be hundreds of billions of them out there. The Andromeda Galaxy, for one, may very well be teeming with life. It is the largest of all the galaxies that surround ours, and it is very close, on a galactic scale, that is. Not on a human one. A call made right now from Earth to some place around one of its 1,000 billion stars would take about 2.5 million years to reach its destination. If we were to make contact, we'd better find an intelligent question to... Now, how big is the visible universe? What would happen if you were to shoot straight out into what can be seen for as long as is possible? Is there a limit to it all? Well, since someone is, sooner or later, bound to ask you that, once you are reunited with your body, you'd better try to figure it out. With confidence, you pick a random direction and head for it. As you start moving away from your home galaxy, you immediately realize that the Milky Way is part of a little group made of 54 galaxies, gravitationally bound to each other. Scientists have called that group the Local Group. It spans a sphere about 8.4 million light-years wide. The Milky Way is its second largest member, Andromeda being the king. Beyond lie other groups of galaxies. Some of them are several hundred galaxies strong. These big gatherings, much larger than ours, are called clusters of galaxies. As you keep shooting ahead, you fly by giant clusters, superclusters, containing tens of thousands of shining spirals and oval disks made of countless stars and black holes, all bound to each other by gravity and stretched throughout space and time. These superclusters form mind-bogglingly large structures. As you shoot away from everything you know and look at the universe on a different scale, you realize that you will once again have to reconsider your relative size in the grand scheme of things. Your mind's eye wide open, you turn around, and you look everywhere, gathering as much light as is possible from all possible directions, searching for an end to all this. There is no notion of up or down, no difference between left and right. You are now more than 1,000 million light-years away from the Earth, and billions upon billions of shining galaxies are spread throughout an unbelievably large darkness. Around you, near and far, galaxies and groups of galaxies and clusters and superclusters are separated by distances larger still, larger even than all the distance you've traveled so far. That the Milky Way is but one of all these dots is barely believable, and yet you know that what you see is no fantasy, but what is known to mankind. Still, true facts or not, the idea of saving the Earth no longer seems to make any sense at all. Why bother? Why care? Understandably, leaving everything behind and letting yourself forever drift in this beyond beautiful hugeness of a reality even becomes an appealing dream. Why not spend your life up there? Is that what scientists do, daydreaming in their laboratories? As you contemplate the idea of never returning to your daily life, a strange feeling catches you and begins to inject a new energy back into your mind. Somehow, all you are now seeing, all you are now moving through is what mankind understands the universe to be. Somehow you are traveling through the universe, as it is pictured by human minds. So all this immensity has to be contained within the limits, if there are any, of a human brain. As amazing as it may sound, it is a reassuring idea, and it brings you back to being a human being, a member of a species able to project its thoughts as far as the eye can see and far, far beyond. Embracing the spacescape, you wonder, could the magnitude get still bigger than this? Could your mind embrace even more? Whatever the fate of the Earth, you decide that you'd rather know than not. Your virtual heart thumping with renewed curiosity, you desperately head forward and fly past thousands of millions more galaxies. As is invariably the case with humans, familiarity soon sets in, and even the universe's immensity ceases to shock you. What may have felt like desperation a second ago now seems to have turned into joy. Here and there you see galaxies colliding, you see stars bursting into superstars, supernovae, outshining billions of their siblings for but the wink of an eye. Throughout the universe, everything moves around everything. You are being blessed by a show of amazing proportions and inhuman beauties. Heading forward without looking back, you are now 10 billion light-years away from Earth. Your mind keeps flying ahead and away. You are 11 billion light-years from the Earth, 13 billion light-years away, and counting. And you now feel elated, and you look for the end of our universe, and you see none, but your mind slows down slightly, for the galaxies around are getting scarcer, and the stars they are made up of seem to be getting bigger. Enormously so, in fact. Some of the stars you now see are hundreds of times bigger than the average stars of today's Milky Way. You keep moving forward, albeit at a slower pace. The number of shining sources of light in front of you has now fallen drastically, and as you reach a distance of about 13,500 million light-years away from Earth, pretty much all sources of light are gone. Could you possibly have reached what you were looking for? Does the universe actually have an end? You remember having raised the question a couple of times with your friends prior to your tropical island trip together, but you had never given the thought a real meaning. And now you wonder, did you think you could eternally zoom out from Earth into the outer universe and continue to see galaxies? Well, since you are traveling through the universe as it is seen from Earth, let me say this. Our telescopes have shown us different. There is indeed a limit to what we can see and will ever be able to see using light. Your mind hasn't reached that limit yet, but it soon will. For now it is traveling through a place so remote in space and time that the first stars weren't even born. For this reason, the place and epoch you are crossing has been dubbed the Cosmic Dark Ages. Any light we see coming from there has traveled throughout the universe for 13.5 billion years to reach us. It is back then, in a stretch of time lasting about 800 million years, that the first stars began their job of transforming small hydrogen and helium atoms into the matter we, and other planets and stars, are made of. These were the first generation of stars, our Sun being a second or third generation one. As you continue to fly forward, expecting the darkness to prevail forever, you suddenly reach a place through which light cannot travel anymore. The surface of what seems to be a wall in space and time. Beyond, the universe is not dark, it is opaque. You stop right in front of it and cast a virtual hand forward to gently probe what lies beyond. Goosebumps spread over your non-existing flesh as you touch what seems to be a tremendous amount of energy. An energy so dense that you suddenly understand why light cannot travel there. It would be rather like lighting a torch within a wall. Light exists beyond the surface you are facing, but it has no freedom to travel at all. What you have reached is not a product of your imagination. It is the furthest place our telescopes can see. It is the place in space and time where and when our universe became transparent. No light from beyond, no light from before that time will ever reach the Earth in a straight line. No light from before that place will ever be caught by any of our telescopes. It took many decades for theoretical physicists to understand what this meant. In the end, as you shall see in the next chapter, they came up with a rather bright idea to make sense of it all, and this idea is called the Big Bang Theory. For now, however, you'll have to accept that you just reached the end of the visible universe. It is a surface that has been detected and mapped with our telescopes. The surface of a wall that no light can cross. It has been called the surface of last scattering. But just as you start realizing how weird and unexpected all this sounds, everything disappears around you, and you find yourself back on your tropical island beach, looking up at the night sky. The stars are still there, and so are the trees and the sea, and so are your friends. They are looking at you in a rather peculiar way. You sit up and tell them the extraordinary journey you've just been on. The sun dying. We need to find a solution to that problem. The universe so big it's crazy. And the wall. Out there. The wall that marks the passage from opacity to the Dark Ages. Your friends' peculiar looks turn into worried ones. As they help you up and walk you back to your villa, you can hear them wonder if perhaps the barbecued shrimps were not fresh or the alcohol too strong. To the east, a few hours later, some of the rising sun's rays begin to bounce off the dust contained in the Earth's atmosphere, especially the ones corresponding to the color blue, diffusing all around, hiding space away from view. Lying down on your bed, surrounded by early morning birdsong, you open your eyes and see the silhouette of one of your friends standing right next to you. She apparently kept watch over you throughout the night. Did you dream it all? You again wonder. Did your mind really travel through the vastness of space? As your friend asks you if you are feeling better, holding a glass of water out for you, a fresh morning breeze gently caresses your forehead, and you smile, thinking that either way it feels good to be back on Earth. And then you smile even more, for deep inside yourself you know that you experienced something very special and dreamt none of it, that it was all true, that you were blessed with seeing without having to study for years. For some reason unknown to you, you saw the universe as it is known today. Relieved to see you smile, your friend stands up to fetch you some breakfast. As soon as she is gone, however, you immediately try to recall what you've been through, not to forget, with the feeling that this was only the beginning of a very strange adventure. Sitting on your bed of woven palm leaves, watching the waves wash over the seashore, you remember the Earth as seen from space, a tiny dot of blue orbiting the sun. You remember the other stars, billions of them, swirling around the central black hole that hides near the center of the Milky Way, our galaxy. Then you remember Andromeda and the 4 dozen or so galaxies that make up the local group. And then you remember the other groups and galaxy clusters and superclusters that spread far to infinity and beyond. No, not to infinity. To the Dark Ages and the Wall, the surface of last scattering, beyond which no light can travel freely. And you know that whatever direction your mind might have taken on its journey, you'd have ended up hitting that wall. This pretty much sounds as if, on a scale much larger than anyone could ever imagine, the Earth was in the middle of a sphere whose boundary is made of that wall. What lies within that sphere may well be the entire visible universe that will ever be accessible to mankind. As you let that thought sink in, you blankly stare right in front of you, at the horizon. If the surface of last scattering surrounds the Earth, then the Earth has to be at the center of the sphere bounded by that wall. That sounds logical, but then that means the Earth is at the center of its visible universe. Shocked, hardly believing it yourself, you shake your head and mutter that none of this makes sense. It makes no sense at all. Still, you know what you saw, and you suddenly wish you could get back up there and have another look at it all, which you will, but from a different perspective, very soon. To prepare yourself, let me just say that the surface you saw, the surface of last scattering, is not the end of the story. There are at least 2 other surfaces beyond, with walls behind them. The first one is called the Big Bang itself. The second one hides what caused the Big Bang. Before you reach the end of this book, you'll travel all the way to that second wall and beyond. But first, you should take it easy. You are on holiday after all, and your friend is back with your breakfast. While you eat, however, I'll help you bring some order to what you've been through.